Today we are going to write the chemical formula for aluminum carbonate. The first thing that we must do is write the cation symbol and the charge. If we reference the periodic table, we can look at group 13, the boron family, and we find aluminum. Because it is in group 13, we know that aluminum has a positive 3 charge, and because it is a positive ion, this means it is a cation. So we write Al plus 3. The next thing that we do is find the anion and write the symbol and charge. We know that carbonate is CO2 to the negative 2. Because it is a negative ion, we know that this is an anion. The next thing that you do is reduce the charges, but because you cannot reduce these charges, we simply cross them over to the other side. First, you bring the 2 from carbonate to aluminum and write Al subscript 2. The next thing that you do is cross over 3 from aluminum over to carbonate. So you write CO subscript 2 subscript 3. However, you do not multiply these two subscripts because you need to make sure that the CO2 remains carbonate, and if you multiplied them, it would no longer be carbonate. Today we are going to name the chemical compound AgCl. The first thing we must do is determine whether this is ionic or covalent. If we look at silver, it is in group 11. This means it is a transitional element. It is on the left side, and therefore it is a metal. The next thing we look at is chlorine. Chlorine is in group 17, the halogen family, or the fluorine family. It is on the right side, and this means that it is a nonmetal. Because we have a metal plus a nonmetal, we can determine that this is ionic. The next thing that we need to do is determine the type of cation, or positive ion, that we have. We know that Ag, or silver, is a cation, or positive ion, because it is a metal. Next, we must determine whether silver, the cation, is a transitional or regular element. Because it is in group 11, it is a transitional element, because transitional elements make up groups 3 through 12 in sublevel D. Next, we must calculate the charge of silver. Because we've memorized our polyatomic ions, we know that silver has a charge of +1. Next, we must use the Roman numeral, but because silver only has 1 charge, we do not put a Roman numeral, and we only write silver once. The next thing that we need to do is determine whether our next element, chlorine, is a polyatomic ion or not. It is not, but rather it is a nonmetal. Take the root of chlorine, which is chlor, and add ide. This means that we have silver chloride.